third speaker is Alisa Adhikari from the Duke University Medical Center, working with Dr. Murali Duraswamy, graduated from Duke University, bachelor's in neuroscience and global health. Currently taking a gap year. I wish I could take one. To investigate some of the interesting things, including environmental equity and hopefully brain health. I think that.
Thank you for that introduction. And I'm happy to be here today to present to you all. Given the current interest in the exposome of Alzheimer's, which you've already heard a little bit about, as well as climate change and environmental equity, I hope to be able to kind of link some of these factors and then give maybe a little bit of future direction. So as Julia has already mentioned today, there has been a lot of work that has been done in terms of individual kind of exposome factors, such as environmental factors or socioeconomic factors that have been individually linked to health cognitive impairment or Alzheimer's disease in terms of diagnosis and prognosis. Some examples from earlier today were the presence of lead or water toxicity, as well as education level and socioeconomic status. However, very few studies have attempted to link a comprehensive set of these factors to an individual or a geographic area in order to kind of put those together and develop a comprehensive view of how that affects health and including neurocognitive health as well. So no study, as far as we know, has been able to lead such a comprehensive list in terms of a AD clinical trial data set, which is the goal of our presentation. So before we start talking about our work itself, I'm going to introduce the database that we used in order to do it. It is called the Environmental Justice Index, which I'm going to refer to as the EJI as we continue. It is the first national geographic-driven tool and has been designed to measure the cumulative impacts of environmental burden through the lenses of human health and health equity. It is composed of 3 different modules, the first being environmental burden, social vulnerability, and then the last being health vulnerability. And all of these modules have a total of 45 variables included in them. And all of those variables will be ranked together to come up with a single cumulative impact score called the Environmental Justice Index. And that is ranked across each of the census tracts in the US. So that is the geographical region that we're looking at as a census tract. And that is the smallest geographic region that will be included in the EJI. It was developed in 2022 by the CDC and the ATSCR. And with the goal of hopefully giving policymakers and community members alike kind of a view of which areas may need more resources in order to achieve the goal of environmental justice. All right, so now I'm going to give a brief look into the output for the EJI Explorer. Okay. Here we have a view of Durham County, which is outlined here in black. And then within that county, you can see the smaller areas, which are kind of outlined in gray, which might be a little harder to see in the back, but they are color coordinated from low to high on the EJI ranking scale, which you can see over there. The lightest being the low ranking, and the higher being the darker. And then the area that I've highlighted with the red arrow is in the central part of Durham and is classified to be high on the EJI ranking scale. This classification is based on these variables that you can see here. This is just a subset of them. If I were to scroll through, you can see each of them is numerically ranked from 0 to 1. But just as an overview, the one cumulative number that I was speaking about earlier is the EJI rank, and that is a total of all the variables that are included within the EJI and then given kind of put together to come up with that one number. And that is what is being ranked with high. It also includes the environmental burden rank, which is one of the 2 modules that I was discussing, and the social vulnerability rank as well. And then if you were to scroll lower, you can see kind of more of those variables individually. And then the important part for us in terms of research in order to get this information is that people who are coming from these areas may have different characteristics in comparison to those who are coming from other areas inside Durham County. And that will have an impact on how their environment will impact their health and how we can account for that in clinical trial data as well. All right, so this is the environmental burden module and all the variables that are included within it. On the right side, we have the categorical variables: air pollution, potentially hazardous and toxic sites, built environment, transportation infrastructure, and water pollution. Each of these categorical variables includes at least one, if not more, individual variables within it shown on this side, with the definition also given. Each of these variables is given a ranking, a percentile ranking from 0 to 1. That is how they are classified in the EGI index. So 0 being the most well off, and then 1 being the most disadvantaged in relation to every other census tract that is ranked in the US for each of these variables. So how the EGI works, just to give a little introduction to that. With all the individual variables being ranked from 0 to 1, these categorical variables are then again they take into account the individual variables, and then you give one categorical ranking for example, for air pollution, for hazardous and toxic sites, built environment, and transportation infrastructure, as well as water pollution. And then all of those together will then again make up another measure of the environmental burden ranking. And that is how one of the modules will be created, and then the social vulnerability module also models the same pathway. And those will be put together the EGI rankings. This is the social vulnerability module, given the same kind of way, with the categorical variables being racial and ethnic minority status, socioeconomic status, household characteristics, and housing type. And then we have individual variables in the second column. There is also a third module, which I will not talk about here very much, except to kind of introduce it. It is the health vulnerability module, and we don't use it in respect to using other health variables, because we used cognitive testing in our the study that we linked this with, and so we cannot use the health vulnerability module in conjunction with that. But it does include measures of prevalence in terms of like 5 more common chronic conditions, such as diabetes and cardiovascular disease. All right, so now that I've given an overview of the database, we're going to talk more about the study. So the aim with our study was to link these environmental and social vulnerability measures to a clinical trial data set that we were working with. The subjects for the clinical trial itself was a project clinical trial, which was run a couple of years ago and published the results in the NEJM last year. All of the subjects that we had, 107 of them, were recruited from 2 different sites, in New York with Columbia University, and then in Durham with Duke University. And all of the subjects, all 107 of them, have mild cognitive impairment, and we're kind of stratified into that. We'll talk about it in a little bit. The data that was collected was the data that we used for this study, I guess, more so than what was collected. We had a longitudinal cognitive data given from the first week to the last week in the study, which is at the 78-week mark. So we were using the longitudinal measures to the difference between the last and the first cognitive scores. And we used their home addresses to put into the EJI to kind of pull out those geographical numbers that we discussed a little bit ago. And then this is the baseline demographics of our MCI sample. And here you can see that I've divided the group into non-Hispanic whites and minority groups. The minority groups as a whole were comprised of Blacks, Latinos, and a few Asians as part of our participant sample. And as you can see here, New York City did pull more of the minorities than we did, but even so, there's not any difference in cognition at the baseline between non-Hispanic white and minority groups, which we can see in the last 3 rows here. EMCI and LMCI are just staging in the cognitive impairment process, so just early and late stages. And there's not any significant difference between those 2 groups in the in the non-Hispanic and minority groups. And then further going down these last 2 rows are 2 types of cognitive testing that are commonly used in Alzheimer's disease diagnosis and then staging as well. So the MMSE is a mini mental state exam, and the ADAS-COG is another measure as well. And as you can see, there's no difference in baseline level for the non-Hispanic white versus the minority groups. All right, so just to give a quick overview of the 2 sites. Here I'm showing New York City in the coral color, and then Durham is in blue. As you can see here, there is a significant difference in all 3 of these larger variables: environmental justice index, the environmental burden ranking, and then the social vulnerability ranking for between the New York and the Durham sites. And then particularly for the environmental burden ranking, New York City is well above the national median at 0.5, especially for that measure itself. And for all of them nearly twice as much as exposure as the participants that we had in Durham. And then going on, there's a similar graph, this time being shown for minorities and non-minorities. The non-Hispanic whites are being shown in green, and then minority groups are being shown in purple. Again, with the same variables, environmental justice index, environmental burden ranking, and then social vulnerability ranking. And then here again, you can see that minority groups have an average that is significantly higher than non-Hispanic white groups at every single one of these three larger variable sets. And this is significant in terms of their exposure to pollutants and then their social vulnerability measures as well, and how they may affect their health going forward. This is kind of a complicated graph, but gives the individual kind of variables for each of the variables within the environmental module. And then at the very top, we have the overall environmental burden ranking at 12 o'clock, and then kind of going around the circle, we have each of the variables being represented with some points. And again, I have non-Hispanic whites being shown in green and minority groups being shown in purple. Here you can see again that with more detail this time, with minority groups having significantly higher exposure to air toxins such as ozone, diesel particulate matter, and air toxic cancers, which are just particular particles that have been shown to be causal in terms of cancer. And furthermore, we have other variables that are being shown around the graph as well. And some of them we can see in kind of toward the bottom area. A lot of our sample didn't have any strong effects of being close to particulate toxic release inventories, kinds of things like that. And so a lot of the averages are closer to zero than that. And then similarly with airports, there's not a lot of exposure within our sample. And so that is also closer to zero for all of our participants. And then I will show it again. Okay, sorry, that is the national median at 0.5. And this is it again for the social vulnerability ranking. And then it's even more exasperated than I would say that in the environmental burden ranking itself, where we can see that minority groups have a lot more exposure to poverty or living in areas where people are less likely to have a high school diploma. And that is much more prevalent in minority groups than it is in participants that are non-Hispanic white across both of our two sites. You can see that going forward across most of the variables. And then social vulnerability ranking itself is quite a bit higher for our minority population than it ever was for the non-Hispanic whites on average. All right, and I guess to conclude a little bit, I am showing here a scatter plot that shows the environmental burden ranking score on the x-axis. And then on the other axis, I have the change in ADAS, which I talked about a little bit ago, we took the 78-week minus the first week and kind of just wanted to look at how those scores change over time. There was an RPET, but neither of those were significant or very strong in correlation. And as you can see, this is kind of replicated as we went across the different cognitive variables we used. We had done a couple of like OMSC and the functional assessment questionnaire as well in terms of relationship with the EJI, but there wasn't very much strong data that indicated that the EBR score and the EJI scores were very linked in terms of 78-week change in those cognitive scores. And then to conclude, this is the first study, as far as we know, to link these EJI indices to a prevention trial for Alzheimer's disease. And then it demonstrates the feasibility of linking the EJI indices to future clinical trials, and we hope that that continues. The EJI demonstrated site-based differences between the New York and Durham site, as well as the differences between the minority and non-minority groups at neighborhood and smaller environment. All right. So with that being said, and we hope that there are future clinical studies with larger samples and population-based samples that we can use with the EJI. As you can see here, we did have 107 participants, which is a relatively smaller sample size to start with, but we hope to continue hopefully with the larger data sets as ADME in order to kind of look at a larger sample of cognitive range as well, because all of our participants had MCI, they were diagnosed with MCI coming into the study. So now it would be, I think, beneficial to look at a larger cognitive range, go from everyone who's cognitively normal, who has MCI, and then also those who have Alzheimer's and dementia to kind of look at how that risk may change over time. And then the EJI metrics themselves kind of have limitations within them. So we don't really, all of the variables are collected in different ways and also have different time periods of collection. So some of them may be collected over the last 2-year period, others may be over the last 4-year period, and so on. And so there's no way to like pinpoint when that data was collected. It's like how you can apply it to the database that is available today. And then we cannot measure a household level exposure. Like I said, the geographic data that we're looking at is census tract based. So we cannot go any smaller than that to determine how a certain neighborhood or a certain household may be impacted by these environmental exposures. So that is a little bit too granular for us to capture. And then kind of related to some of the conversations we were having earlier today, there's no way for us to capture the longitudinal kind of exposure either, because we are collecting their current addresses. And so kind of accounting for maybe, depending on where you want to put the most emphasis in their lifelong trajectory, determining where to kind of ask for their address and what kind of addresses you want to put in to consider. So there is definitely a need for greater cooperation between clinical and environmental researchers in order to obtain that more granular data and determine what kind of variables may be most important for clinicians to consider and how environmental researchers may be able to kind of match the capability of those criteria.
Questions? Alisa is going to be an enlightened physician. We'll go back to medical school. Yeah, is that the plan? That is the plan. Enlightened one, yeah. I'll see it. Okay, questions?
Yes.
Could you go back? Oh, he's taking the slide. Graphics, the graphics were the last slide that had EJI and social vulnerability. Just to have something to look at when talking.
Yeah.
So with these individual, I don't know, aspects that you're looking at, so like proximity to airports, railroads, all those things. Did you look at effects of those individual things that are feeding into this EJI, or just that kind of unified aggregate score?
The individual variables that we were showing earlier, we did look at some of those variables, and some of them, like air pollution, were very much exaggerated in our sample. The participants that were coming both from Durham and from New York City had much higher levels of exposure to air pollution than the national average, which is at 0.5. So here you can see that, like, compared to even that national average at 0.5, our sample had higher levels of that. So we did look at individual variables such as air pollution.
And then one follow up with how the aggregation of EJI works. Like, are all the different variables that are feeding into it treated kind of equally, or how are they aggregated to a single score?
They more or less are treated equally, but I know the EJI has its own like formulas for how they put together all the information, especially for like larger variables such as the environmental justice index of a whole. And for the smaller categorical variables, they're treated more or less.
Thank you.
So first of all, congratulations to you and both Swami getting in New England Journal of Medicine. This is the first step, and clearly, if these EJI can be applied to large data set, theme of today's meeting is leveraging on large data set, would truly help the field to move forward. So back to Dr. Dorsami's question in the last session. So is it a point prevalence, or you were looking at this, people move, as you asked in the previous talk? How would you capture that, these pollutants, these environmental factors? I mean, these may have an effect, as somebody earlier said, starting in infancy or in childhood. Can you separate that by using EJI?
The thing with the EJI is that it only gives like current environmental measures for these geographic areas. So even if that kind of points to two problems. Like the problem with the EGI itself doesn't really account for longitudinal kind of measures like that. So we cannot account for that by itself. But even if it did, it would be a question of how you're going to take that into account. And that is something that we have talked about in the past, but there's no way for us to really, you have to think about what kind of, because the EGI itself is a point measure, you would have to look at what kind of lifelong exposure you want to put on the post and like kind of how you're going to weigh that against every other like place where they have lived, for example.
We're gonna send the question back to Dr. Doswami. Dr. Hussain, Dr. Doswami.
So people are tinkering with attaching sensors to individuals, but that raises a privacy risk. Yes, for a research study, you can do that, but you can't do that in the real world. The second is, can you develop a blood test that gives a comprehensive measure of all of 50 metals and 50 air pollutants?
Yes.
People are working on that, but there is nothing that's fully validated and ready to use with cutoffs.
How would EDNI 4 further expand this? I mean, there are two sites in this. EDNI 4 may have 40 or even more sites.
So ADNI is not currently looking at this. She pointed to ADNI as an example of a biomarker study because it would be interesting to link the environmental exposure to biomarkers in some study. So ADNI is an example. You know, if ADNI would have to modify its protocol if it wants to incorporate, because currently they are not. Okay. But they have a wide range of other socioeconomic exposures. Maybe Monica heads maybe you want to mention.
Oh, sure. So I was actually, so great question. Great minds think alike. Like I was thinking about that as I was listening to your wonderful talk. So congratulations. So, that's something I can take back to ADNI, but we are expanding to at least include the area deprivation index, which takes account at least social adversity and numerous other metrics of sociocultural, exposures like race, like discrimination and racism, socioeconomic status, and others. This is all very new to ADNI, and it's taken a lot to get to this point. But I think this is a really interesting new direction. I will say though, because somebody called on me, so now I'm going to talk. The one thing that I'm a little bit concerned about is really great and exciting. I want to dig deeper. I'd love to collaborate, but it is a little bit concerning that one of the measures for the environmental, I think it was the environmental justice burden. I don't remember which one, but it was just percent of people who are from minoritized backgrounds just living there, right? It wasn't about integration. It wasn't about anything. And to me, that's I don't know. I don't know that. I don't think that's very good. That really jumped out at me, but you've been waiting so long.
Yeah, well, because our study is looking at 5 years, intersecting twice a year with the exposed. We assess how many years they have lived in that area. That's a big factor. How many years have you lived in that area? We have purple air monitors both outside and inside the home. So, so we're looking at that. And I think your point was so well taken that you have to marry the different fields together. My vision, and I was just talking, Dr. Adhikari was just talking to me, next step is blood biomarkers, right? Connecting that with the thing. My swan song, I want to be able to address what Dr. Eisner is saying, and get these people, get mind diet, get exercise, to these people to help start diminishing their risk. And I think your marrying is so important. We have researchers from Colorado who are experts in this agricultural living and also burn smoke. It takes a village.
It does indeed.
Yeah, just, a quick comment, this is a presentation. Congratulations on this work. And there's always been this momentum to link health disparities researchers work to, biomarkers and some more precise, so there's been a lot of discussion around biomarkers. And this is a great, tool for, those researchers to link to environmental structural, so it's pushed in this interdisciplinary space that I think is so critical and important. Thank you for your work.
Yeah, and it is happening just as it would. We are measuring today over 600, 700 environmentally related chemicals to a network of metabolomics researchers. So from metals, we have over 40 metals and so on. And this will be done again in the ADNI. It goes back to the ADNI. We fit in a gap in the ADNI between the chemicals and the diet and the big databases on diet, composition of diet, millions of points. So all of this big data is coming. It's coming. The issue is how do we deal with it? How do we analyze it? And how do we make sense of it?
I'm sure Robert Bullard would be with you.
Can you get that last slide, please? Apologies. Was I reading that correctly, that lead mines had almost zero environmental burden?
It's not that they had zero environmental burden, just that our sample, no one in our sample really had high impact from lead or coal mines. So in terms of their proximity to those.
Is this the one or the one?
That's where they're located.
New York City.
Oh.
That's why I'm saying there are a few variables on here where not a lot of our participants had any kind of impact from those just due to proximity. So a lot of them are closer to zero, just on average.
If you lived in West Virginia, that graph would look different.
Right, so.
I just have a comment to add. That some Norwegian scientist authored an article that's going to be appearing in Mayo Clinic proceedings as a special article. And the gist of it is that the homocysteine, while itself is a toxic amino acid, it's also a marker not only of vitamin deficiency, but also of metal toxicity. And there many metals can actually raise your homocysteine level. So it's a fairly inexpensive marker that you can use to then determine whether you need to do a full set of metal toxic evaluation, which includes not only blood, but it has to include either hair or nail as well.
Cysteine takes you also back to methylation, one
Yes.
part of metabolism and methylation, and all that. There's a lot of connectivity among a lot of things that we are discussing. These are interconnected influences, yeah?
Yeah.
I think the
metabolome.
On the flip side, there have been like at least 6 trials of suppressing homocysteine levels in MCI and AD, which have not yielded results. So the question is, are we intervening at the wrong time or?
Because those studies were people who, they were given vitamins, they were not vitamin deficient.
Right.
They were metal toxic and nothing was done to reduce their metal toxicity.
But if the samples are available from these studies, we can go back and profile
They
and
are.
answer questions.
They are available.
And the same with omega-3 supplementation, and we implicated in cognitive dysfunction again and again and again. Yes, now in the UK Biobank and so on. So why doesn't it work when you get a supplement? Why are the results mixed? Yeah, we need to stratify. We need to do much more.
There are also blood
Yeah.
samples available from metal chelation trials in dementia.
Yeah,
So there have been at least half a dozen trials of chelation therapy to remove various metals, lead, iron, aluminum.
Well,
you can have a design that.
it's, as I pointed out, if you only correct one factor and you ignore the other factors, you're still going to wind up with dementia. So you really have to do a comprehensive evaluation, and then the intervention is often multiple.
Thank you.